Good morning, students. In today's lecture, we will talk about types of water. You might have observed that some water sample does not form foam or lather with soap, while there are some water samples where soaps are effective, or we can say water produces foam or lather with soap. Means if soap is not forming lather with water, then soaps are ineffective. They cannot be used there as a cleansing agent. And if soap is forming lather or foam with water, then soap in that water sample can be used as a cleansing agent. So based on foaming tendency with soap, water is classified into two types. First one is called soft water and second one is called hard water. Soft water, it forms lather with soap. Means soaps can be used as a cleansing agent in presence of soft water. Example, distilled water and rainwater, as these are the purest form of water, so these are called soft water. Now about the hard water, don't get confused with the heavy water. Heavy water is D2. It is entirely different. There is no relation between heavy water and hard water. Heavy water is D2O, where the heavy hydrogen that is called deuterium combines with oxygen to form D2O, which is called heavy water. Hard water is entirely different. So what is hard water? The water which don't form lather with soap, or water which don't form foam with soap, is called hard water. River water and sea water are the examples of hard water. Now, what is the difference between soft water and hard water? The hard water contains calcium and magnesium salts. Salt of Ca plus 2 ion and salt of Mg plus 2 ion. As it can be calcium bicarbonate, it can be calcium chloride, it can be calcium sulfate, it can be magnesium bicarbonate or magnesium hydrogen carbonate, magnesium chloride and magnesium sulfate. If any of the salt written here is present with water, is present with H2O, then that water is called hard water. And here in soft water, these salts are absent. Now, what is the reason why soaps are ineffective in hard water? Say if soap is not producing foam or lather, then it cannot be used for cleansing purpose. If soap is forming foam or lather with water, then it can be used as a cleansing agent, otherwise not. So why there is a difficulty, why we face problem with hard water, why soaps are not effective? Reason? Let us check. What is soap? Sodium stearate is called soap. Having formula C17H35COO minus Na plus. It is a sodium salt or potassium salt of stearic acid, which is called sodium stearate. Now, from sodium stearate, C17H35COO minus part, that is your stearate part, is responsible for cleansing property of the soap, or this particle forms foam, or this particle or ion forms lather with water. If this ion is available in the water, then foam or lather will be produced and it can be used as a cleansing agent. But somehow this part is removed, then it cannot be used as a cleansing agent. Remember, sodium salt of stearic acid is water soluble. That's why soaps can be used with water. But in presence of hard water, we will be having Ca+2 ion produced from calcium bicarbonate. It can be Ca+2 ion produced from CaCl2. It can be Ca+2 ion produced from calcium sulfate. It can be Mg+2 ion produced from magnesium bicarbonate. It can be Mg+2 ion produced from magnesium chloride, or it can be Mg+2 ion produced from magnesium sulfate. The presence of Ca+2 ion or Mg+2 ion interferes with the cleansing property of soap. Now what happens? In presence of hard water, we will be having Mg+2 ion and Ca+2 ion. This Mg+2 ion from the hard water or Ca+2 ion from the hard water combines with stearate ion, as a result of which we obtain magnesium stearate having formula C17H35COO whole twice Mg, calcium stearate, that is C17H35COO whole twice Ca. This part was water soluble. This salt was water soluble, but this salt is not water soluble. Once Mg+2 ion is interacting with stearate ion, once Ca+2 ion is interacting with stearate ion, we will get a precipitate of magnesium stearate or calcium stearate, because magnesium stearate and calcium stearate are not soluble in water. So they will be deposited in the form of scum on the clothes or at the bottom of the any container which is having water, or on the clothes also. Solid particles will be deposited over clothes also. So the stearate ion, which is converted to magnesium stearate or calcium stearate, will be totally wasted. When all the Ca+2 ion and Mg+2 ions are removed, then it will start functioning. Then it will produce lather. But before that, most of the stearate ion will be wasted. Most of the soap will be wasted in the form of scum or in the form of insoluble compound, precipitate. So that's why hard water does not produce lather or foam in presence of soap. Now, about the hardness. Hardness of water is of two types. First one is called temporary hardness and second one is called permanent hardness. What is the difference? Temporary hardness is due to presence of calcium bicarbonate or magnesium bicarbonate or both. While permanent hardness is due to presence of calcium chloride, magnesium chloride, calcium sulfate or magnesium sulfate. Now why? The presence of calcium bicarbonate or magnesium bicarbonate is called temporary hardness. And why these salts are responsible for permanent hardness? Reason is very simple. This hardness can be removed by simply boiling the water. If you are boiling the water, and if you are observing deposition of white color compound inside the wall of the container or at the bottom of the container, you can observe at home. Why it is there? Let me tell you. Calcium bicarbonate and magnesium bicarbonate. These are thermally unstable salt. If Ca plus 2 and Mg plus 2 ion are there in water, then they will create hardness. But if somehow these are removed, then hardness will be removed. Calcium bicarbonate and magnesium bicarbonate are thermally unstable salt. When you boil the water, then it undergoes decomposition. As a result of decomposition, bicarbonate salts gets converted to carbonate salts. It will be converted to CaCO3 and will be converted to MgCO3. These are water soluble salts, while calcium carbonate and magnesium carbonate are not soluble in water. So if the compound is not soluble in water, definitely it will form precipitate. And due to deposition of calcium carbonate or magnesium carbonate, we observe deposition of white color layer at the bottom of the container or inside the wall of the container. This is not fluoride, that is calcium carbonate or magnesium carbonate. Now then comes permanent hardness. This hardness cannot be removed simply by boiling the water. We have to use some special method, some chemical methods. Physical methods are not applicable here. It cannot be removed by boiling. Why? Because these salts are highly stable towards heat. These salts cannot be decomposed on heating. If you boil the water, these salts will remain in the water. It cannot be deposited. That's why permanent hardness cannot be removed by simply boiling the water. We need some special method or we need some chemical methods. By using some chemicals, permanent hardness can be removed. So it's all over about the types of water and types of hardness. Thank you and have a good day.